Okay, so in today's lesson, we learned two new laws of exponents. The first one, we have a power raised to a power. So x to the m raised to the n power. So you'll have x written m times, and then you'll have xm times written n times. So what you're going to end up having is a multiplication. So you'll have x to the m times n power. So when you have a power raised to a power, you multiply. Now, the second example here, we did a quick little procedure to prove it. So let's do x, y to the second power, for example. That means you'll have x times y times x times y. And since everything's being multiplied together, we can use the commutative property to rearrange those letters however we want. So I'm going to rearrange it as x, x, y, y. And then you can easily see that this is x squared, that's y squared. So it'll be x squared, y squared. So in general, we can distribute the exponent as long as everything inside those parentheses is being multiplied. So x y to the n power becomes x to the n power times y to the n power. So let's do a few examples. For 2 to the third raised to the 7th power, using our laws of exponents, we would do 2 to the 3 times 7 power, which is the same as 2 to the 21st power. On the next one, again, I have similar to the variables. Now I have numbers, and some of them are exponents being multiplied together, all raised to a power. And the 13 does not have an exponent currently, but what we need to remember is when there's not an exponent written, the exponent is 1. So if I expand this out, let's distribute that 2. We've got 10 to the 2 times 2 times 13 to the 1 times 2 power times 5 to the 5 times 2 power. So simplifying that further, you have 10 to the 4th times 13 squared times 5 to the 10th power. And lastly, same kind of problem with the variables. We've got variables multiplied together, all raised to the 4th power. So you have x to the 2 times 4 times y, and again there's no exponent, so it's 1 times 4, and z to the 2 times 4. So we'll get x to the 8th, y to the 4th, and z to the 8th. And that is as simple as it gets.